Jai Hind दोस्तों. Today we are going to live stream. We are going to conduct one session on the Arduino multitasking. I am Himanshu Tripathi, scientific officer from Akgec Engineering College and AKGC Skills Foundation. I welcome you all to in this session, and in this session we are going to learn that what another thing or what extra thing we can do with the help of Arduino. And this session we have made on the multitasking using Arduino. So this is our agenda of today's session, that we are going to discuss what is multitasking and multithreading, what is the difference and how these two things are related with each other, and also we will discuss that why we need to implement this multitasking concept or multithreading concept, you may also say, in the Arduino Uno board. The next thing we will discuss about the Arduino systems and why this Arduino system is quite useful for this purpose, and why we should learn multitasking in the Arduino system first. And then we will discuss about our own development environment, that how we are going to make programs, how we are going to write codes to do the multitasking or to run multiple tasks at the Arduino Uno. And then we will discuss some codes. In those codes we will discuss that how we are actually handling these tasks. So I am going to start with multitasking. Actually, whenever this term multitasking comes, what comes in our mind? We generally start to think that multiple tasks, and our processor or our controller is going to execute these multiple tasks at a time. But there are certain constraints. By definition, the CPU executes the multiple tasks at a time. This is basically known as multitasking, and in this multitasking, CPU switches between the tasks so that users can collaborate with each program together. Generally, this is the case when we are using the unicore processors like the microcontrollers or the older processors which are coming with single core. So if we are having single core, we can say that we are having single processing unit, or we are having single CPU, and in one CPU it is not possible to run different tasks at a time. So what processor is doing, it is basically arranging or managing those tasks in such a manner so that it will execute first task, then it will switch to the second, then it will switch to the third, and again it may switch to the first. So in this processes or the task which we are talking about, they share the separate memory and the separate resources. So this thing is multitasking. For example, you can see here we are having multiple processes or multiple tasks that we want to run in our laptop or in our desktop, and these tasks may be, I have opened one Microsoft Excel spreadsheet program. I am also available on the Google Chrome Internet browser, and I am also trying to write some code. So I am available on Visual Studio Code, and in the meantime I am also listening some music. So my VLC player is also active. So we can say that concurrently or at a time we are running these four programs, or we can say that we are running these four tasks simultaneously in our processor. But if I am using a single core processor, how this thing is going to be controlled or managed by? To manage these tasks, to manage the execution of these tasks is the sole responsibility of operating system. Then operating system is a program. This operating system will manage the execution of different tasks. That basically comes into the class of task scheduling capability of the operating system. Then operating system will allocate the memory and other resources to those tasks so that those tasks may run efficiently in one core or in a single core environment. The next term is basically related with the same scenario, and this term is known as multithreading. So there is a difference between multitasking and multithreading. In the multitasking, as we have seen earlier, that we are running multiple tasks simultaneously or concurrently, but in multithreading, our one task may be subdivided into the multiple subtasks, or we can say multiple threads. For example, we are working on Microsoft Word application. It is a very powerful text editor program, and we all are always used to use this program for writing our reports or some other documents. So if we are using Microsoft Word document, you can easily visualize that at a time this document is performing more than one task, or more than one threads are active from this particular process or from this particular task. Few threads I have mentioned here, that our Microsoft Word program may be available to take keyboard inputs, so that whatever we are typing on our keyboard, that thing is to be printed on the Word application program. Also, it is basically running the thread of auto save after a certain time period. It is basically starting saving your text document, and simultaneously while we are typing something, your grammar check or spell check program is also active. This thread is also active, so that we can check whatever we are typing, whether we have typed the correct spelling or not. So this is the example of threads which are basically coming out from a simple one task. Similarly, in our embedded system applications, we can create a task. If we are talking about IoT applications, we may have a client or we may have a server which is reading or which is getting data from other clients, or which is sending data to other clients simultaneously. So this thing is basically known as multi-threading, because one application or one task or one process is actually running on your CPU, and this task is basically further subdivided into multiple threads. So now I think that you have clearly understood that these two terms are having the different meaning. The first term is multitasking. That means we need to do multiple tasks, or we need to do multiple things or processes at the same time. At least user should feel that these tasks are happening at the same time. The second thing is multi-threading. One more thing is important at this point, that we may discuss multi-programming or multi-processing. Most of the time people get confused with multitasking or multi-threading with multi-processing. Multi-processing is a different thing. In the multi-processing, generally we are talking about more than one CPUs. Like if we are using a dual core microprocessor in our system, that means we are having two processors or we are having two CPUs. So what we can do, or with the help of operating system or some other kernel programs, we can divide the responsibility of individual core, that the core number 1 is going to execute this program and the core number 2 is executing the second or different program at the same time. So if really two processes are basically working in the same time, are executing in the same time, then we are performing the multi-processing concept. The next thing we are going to discuss, that what is Arduino systems and why we should use and when we should not use Arduino in our embedded system learning journey. So as all you know that Arduino is an open source platform. Both hardware is open source and the software is also open source. So Arduino is an open source platform and it is very easy to use. You can easily replicate the hardware of Arduino. It is easily available on the web, and you can basically contribute in the Arduino IDE or the programming language as well, because these are the open source projects. So Arduino programming language is basically based on wiring language. It is the basic framework wiring on which the Arduino programming language is based. It is a combination of C and C++ language, and Arduino IDE is also a quite popular program, quite popular framework. And in this Arduino IDE, we are using the processing IDE. The mother IDE or the basic platform is a processing IDE. On the top of that processing IDE, Arduino team has created the Arduino IDE. So Arduino is a very powerful program. If you are a beginner and you want to learn something, you want to learn something in the field of electronics, or you want to learn something in the field of embedded systems or coding, then you can simply start your journey with the help of Arduino. The basic board of Arduino family is the Arduino Uno, I am showing you the diagram, showing you the picture of Arduino Uno here, and the few things that we need to remember, that Arduino is not a full computer, it is a microcontroller based board. Arduino is the name of board, or you can say it is the name of company which is providing you the open source hardware and software platforms. It is not a computer, it is not a dedicated or much powerful computer, it is a simple microcontroller. You can easily see here in the center of this Arduino Uno board there is a chip that is the heart of this Arduino board, and it is a microcontroller. Generally, in case of Arduino Uno, we are using Atmega 328P microcontroller, which is a 8-bit microcontroller from the Atmel, now known as the Microchip company. But in this board, we can also see that here some more components are included. You need to be sure that whether you really need these components while you are designing your product or designing your projects, or these components are just to help you out in your development process. So in this section, in the left hand side of this Arduino Uno board, we can see that we are having one push button. This is a USB A type connector, this is the DC barrel jack. You can provide the power supply using the adapter through this DC barrel jack. These are few capacitors, and this is the voltage regulator IC, so that you may get 5 volt as well as 3.3 volt from this Arduino Uno board. And the important thing is this, again one more Atmel IC on the board. This IC is again a powerful microcontroller, and which is dedicatedly perform here the task of programming. Like when we say that we have written a program on our system and we need to transfer that program to the Arduino Uno board, that means we are connecting our Arduino Uno board using this USB cable, USB socket to the USB socket of our laptop or desktop. And this IC is basically doing the program, that it is receiving the serial data coming from this USB port, and it is flashing that serial data or that program into the memory or flash memory of this main Arduino microcontroller, that is Atmega 328P. So this is it about the Arduino hardware. The next thing that is important while we are using Arduino is that it does not run a full operating system. Actually, any 8-bit microcontroller is not running a full operating system. There is no operating system which can support to 8-bit microcontroller as well. So we don't have any operating system here. This is going to be a challenge for us, because we were talking about the multitasking, and I have told you that multitasking is a feature that can easily be provided from the operating system. But in case of Arduino Uno, operating system is not present. Then also we need to some tricks, some clever tricks that we can perform multitasking with the Arduino Uno. The next thing is Arduino is the main purpose of Arduino is to interface the sensors and devices with this microcontroller, so that we can get data from sensors, or we can, on the basis of that data, we can actuate certain devices like DC motors, servo motors, solenoid relays, or valves, etc. It is great for hardware projects in which we simply want things to respond various sensor readings and the manual inputs. This is the Arduino Uno board. It is good for beginners, it is good for hobbies, but certainly it is not the end for the engineers. Because if you are an engineering student and you want to learn the embedded system concepts, you want to design certain products, or you want to work with some corporates which are indulged into the design of embedded systems, that means you need to work with some bare metal microcontrollers. Like if we are using this complete Arduino board in our product design, then this we are wasting the resources, we are wasting the money. The work is being performed by this Arduino Uno microcontroller, that is Atmega 328P, Atmega 328P microcontroller. So in most of the application, what we can do, we can put this microcontroller on our PCB or the printed circuit board, and we can program our microcontroller so that we can get the desired output. Similarly, instead of Arduino, we can go for some more powerful or more advanced microcontrollers. Nowadays in the field of IoT, ESP32 is providing a good solution for the IoT or embedded system needs altogether. The next thing we are going to discuss about the development environment, For the development environment, as you all know that we can use Arduino IDE, but here I am recommending to give it a try. This is Visual Studio Code, again an open source project from Microsoft. It is a good powerful text editor program. You can write a program of almost any language on this particular text editor. So, Visual Studio Code basically combines the simplicity of source code editor and powerful developer tooling like IntelliSense, code completion and debugging. Remember, while we are using Arduino IDE, we don't have any debugging facility. For the debugging purpose, we generally rely on the serial monitor, which is available on Arduino IDE. But in the Visual Studio Code, we may use the debugger tool to debug our programs more professionally and more efficiently. So, we are going to show you the programs which we have written on Visual Studio Code, and along with this Visual Studio Code, we are also using one more plugin with the Visual Studio Code, and the name of that plugin is Platform IO. So, here I am simply or quickly explaining the difference between the Platform IO and the Arduino IDE. So, on the left hand side of the screen line, you can see that we are talking about the similarities which are found in both programs. This is the Arduino symbol, so you can say these features are available inside the Arduino IDE, and this is the Platform IO symbol, so you can say that these are the features which are available inside the Platform IO. So, the key features, that code editor is available, we may be able to write the code, we can write the code on this editor. Syntax highlighter is available, like if we are using functions, if you are using different type of variables, integer, characters or something else. So, these things are basically represented with some different colors. We are having board managers, we can manage different boards basically coming from the Arduino family or from the non-Arduino family also, non-AVR families also. Like ST is also providing some boards, or expressive boards can be programmed using with the help of Arduino IDE. Then compiler is there, because we are writing code in somewhat in C or C++ language, we need to compile these programs. So, compiler is available in both the programs. And then uploader tool is available, so that we can transfer that code that we have written in our laptop or in our desktop systems, we can transfer that code to the Arduino boards or the microcontroller. Then library manager is a powerful tool in case of Arduino IDE and Platform IO both. Here you can take help from the different libraries while you are trying to interface different sensors, then you can use or utilize the different libraries in your project. And serial monitor is also available in both the cases. The key features which are available inside the Platform IO, and these features are not available inside the Arduino IDE, and here is the main reason why I am recommending you to use the Platform IO and VS Code all together to develop your projects or your applications on the embedded system or Arduino boards specifically. So, here the debugger is available inside the Platform IO, that we need to learn, or we should learn how to use debugger tool to debug the programs of Arduino or any other microcontroller. Then version control system is also available. If you are a user of Git or GitHub, then you can understand easily what is version control. You may write your code on your system, and you may sync your codes with the Git repositories of your own, so that you can later on you can easily track the changes that you have made over a period of time. Then IntelliSense and autocomplete, these two features are very handy when we are basically using the Arduino, we are using the Platform IO tool with the plugin with the VS Code. While we are writing some functions, or we are writing something like digital read, so as soon as I will start writing digital, then it will automatically suggest me that it may be digital read, and on the press of enter we can complete our statement. Then automatic serial port detection is also available. Remember, when you connect your Arduino Uno board with the your laptop, you need to select this correct serial port. So, these are the few reasons why I am suggesting you to use the Visual Studio Code and the Platform IO for your development need. So, that is it guys for this discussion. Now, it is time to get some hands on, and now we will see that how we can program, or how we can do multitasking with our Arduino Uno board. So quickly I am navigating to my Visual Studio Code setup, and here I just want to show you that this is the first program. There I will tell you that how multitasking is being initiated in a single core microcontroller, a single CPU microcontroller. Here we are trying to do multiple tasks. So the very first thing, what is the hurdle when we are trying to implement multiple tasks? In most of the Arduino programs, you must have used the delay function. If you are using the delay function, then you are not doing multitasking. You cannot do multitasking instead, because delay function is blocking in nature. Whenever we are using delay function, it blocks the execution of code, and no other function can execute until the delay period is over. So while we want to do multitasking with our Arduino Uno, we have to do first thing that stop using delays in your Arduino Uno program. So if we are not using delays, then how we can write codes for Arduino Uno programs? So the first example I am basically taking here is the blinking of an LED. That is a very basic and fundamental example. Whenever we start our journey with the Arduino Uno, we use the onboard LED, or we can connect an external LED with our Arduino Uno board, and we just try to turn it on for a certain time and turn it off for a certain time. So here it is a code. You can say that I am using millis instead of delays. So we have to include the Arduino header file in case we are using the platform IO. Here you can see the input of the visuals of platform IO here as well. Okay, this is the logo of platform IO. So here is the code. So we have to include the arduino.h file. I have included it. Now we need to define the pins, in which pin we are connecting our peripherals. So here we are going to use the LED. So I have written static int LED pin 13. That means my LED pin is pin number 13, digital pin number 13. Here we are using some global variables. When we are using some global variables like LED state, it is an integer type variable, and by default value it is having the low. Then the interval, that is 500, we are going to remain turn on or turn off LED for 500 milliseconds, and the last update time. Here you can see the setup function here, that pin mode, LED pin, the output. Now we have declared that LED pin is an output pin, that certainly it is. And inside the loop, what we have written is, if millis minus last update is greater than interval, then we'll update the last update variable and we'll toggle the status of LED. To explain this program, the important point is millis. Millis is a function that is available inside the Arduino IDE or inside the Arduino framework, you can say. So millis is a function. Whenever we start millis, it starts the count of time. And whenever we call millis, whenever we start the Arduino, millis basically start the count of time, and whenever we call millis, it tells what is the current time. Like we have started Arduino, millis is having value 0, and now this value is going to be incremented with time in a linear fashion, and after 10 seconds, if I am again calling millis, it will say that it is having a value of 10 seconds. So after 60 minutes we are calling the millis, it can say that we have a value of 60 minutes. So this is how we are going to track the time using the millis. So if you clearly if you see that what we did in this code, like we are checking a condition millis, that what is the current time. Whenever I am asking millis, that means I am asking our Arduino that what is the current time. So what will be the current time minus last update? Initially we have done last update is equal to 0. That means this current time minus last update should be greater than interval. So if this value, this arithmetic expression is greater than 500 milliseconds, as soon as it will cross the value of 500 millisecond, the condition will hold true. If this condition is true, then we will come inside this if block, and inside this if block what we will do, we will update our variable, that is last update, when we are updating the LED status. So here we are updating the LED status after 500 millisecond. So whatever will be the time in millis, it will be stored in this variable last update. Then we will toggle the LED state. This is the statement which will basically toggle the LED state, and we will write this new state with the LED pin, so that our LED will turn on or turn off depending upon the value of LED state. So the next time clearly you can see that this code is running because it is a forever loop function of the Arduino. Then again it will check the value of millis and the last update, and now the last update value is going to be 500 millisecond, and millis maybe let's say 502 503 millisecond. Then this difference is certainly is not greater than equal greater than 500 milliseconds, so the condition will not hold true and we will not enter in this if block. So in this time we can execute some other instructions which are written before the if block or after the if block. So this is how we can use millis in our program. Quickly let me show you some another program so that you may understand it better. Let me close this folder. Till the time, if you are having any query, if you are having any doubts, you can write your comments into the comment box. Okay, this is again we have written the same program, but this time we are using two LEDs to blink. So if we are using two LEDs, you can easily see that what I did, I included one more variable for second LED. In our first program we were having LED pin, now I am saying that we are having LED pin 1 and LED pin 2. In the previous program we were having LED state 1 and LED state 2, now we are having these two LED states, these two blink intervals, these two last update times, and the program is looking same. These two if blocks are also available inside our loop program. The first will be controlling the state of first LED and the second if block is controlling the second LED. So here we can draw a very simple conclusion to understand what are the state machines. So here these things or these variables are basically acting as the states, like we are basically checking what is the last update time, what was the last update time, and what is the blink interval, and whether this last update time is exceeding this blink interval. Then we need to change the state of LEDs. So these variables we are calling, these are acting as states, and this if block, this complete if block is acting as a machine. If these variables holds true, these variables make this condition true, then this machine will basically start the execution, and it will be responsible for changing the state of LED. So this is the concept of state machine, and we can use this state machine concept in our Arduino programs as well. But the key point that I want to make here is that if we are using this state machine concept, and if we have to interface 10 similar devices, then we need to define 10 states for each device, and we need to define 10 machines for each device. So to get rid of this problem, we can include the object oriented programming concepts inside our Arduino. So if we are talking about the object oriented programming concepts or OOPS concept, we can include the concept of class in our Arduino. So let me show you the next example where I can show you what is the class and how we can create class, and we can solve this problem of LED blinking. And this time I am not going to solve the problem of LED blinking. Codes, Arduino experiments, and let me quickly jump to the code number 4. Great. This is the program. Great. So here we are not going to blink the LED, but we can say that we are going to flash the LEDs. So if we are saying that we are flashing the LEDs, that means the turn on time is going to be different with the turn off time. LED is going to be turned on for a certain time, and it is going to be remain in turn off mode for a different time. So same is true for second LED, it may be true for the third, fourth, and the many LEDs as well. So here I am quickly showing you that how we can define a class for that particular state machine, so that we can initialize, or we can basically make the instance of those classes, those class to control the different LEDs. This can be hold true. This can be true in case of we are basically targeting some other devices like push button switches or servo motors or DC motors, multiple motors in our case. So here I am showing you that here we are going to write a class. For this class we are using identifier class, and we are naming that class as LED flasher, and whatever the states or the variables were available in our previous program, we are using the same variables like integer type variable LED pin and LED state. And I have told you that this time we are going to have different on and different off time. So we are using unsigned long on time and off time, then unsigned long last update. So here the public constructor for this class is public, that LED flasher, and whenever we create an instance of this class, we need to provide the pin that at which pin LED is connected, and the on time and the off time. So here we need to define these things like LED pin is the pin, and on time is on, off time is equal to off, LED state is equal to low, LED update is equal to 0. The next thing is the member function of this class. We need to update the status of LED. So if we want to update the status of LED, we need to write a function, or we need to write a machine in the state machine terminology, which will take care of changing the state of LED. Here what we are doing, we are using a variable, local variable is current millis, and here we are taking the value of millis. Again we are asking to the Arduino that what is the time now. So we are using millis function, and it will basically save the current time inside this variable current millis. So if LED state is high, previously LED state was high, and the current millis minus last update time is greater than or exceeding the on time, then we need to turn off the LED. So if we want to turn off the LED, we can update our last update variable with this current millis, because this time we have decided that we need to change the state of LED, and LED state is equal to low. Now we have made the LED state is low, and we are writing this new LED state with the LED pin. So if this condition doesn't hold true, or previously LED state was not high, it was low, then again we are checking whether the turn off time has been completed or not. So to check the turn off time has been completed or not, we are basically subtracting the current millis values with minus last update, and we are checking whether it is greater than off time or not. If this condition holds true, we are going to change the LED state in our Arduino board. So this is the class that we are going to use. This is the class that we are going to use for the multitasking. And here the objects from the classes, like we are creating the instance of the class. We have created first instance LED flasher, and the name of this instance is LED1. And I have told you that whenever we are going to make the instance, we need to provide pin number, the on time and the off time of that particular LED. So here LED flasher is equal to LED1, and this LED is connected with digital pin number 13, and the turn on time is, let's say it is 333 millisecond, and the turn off time is 999 milliseconds. Then we have created another instance for this class, that is LED2, and here this LED is connected with pin number 8. Let me make it pin number 12 so that I can show you the result on our hardware. And the on time and off time is as 888 milliseconds and 444 milliseconds. We can easily change the on and off time as well, like we can say that it is going to be turned on for 500 milliseconds and turn off for, let's say, 750 milliseconds. Okay. Now the Arduino functions that we have to use, if we are using the Arduino framework, then we have to use the setup function. In the setup function we don't have anything to do, because generally in the setup function we define the pin status, whether this pin is output or this pin is input, and that task we have completed inside this LED flasher constructor or the class. That pin mode is LED pin output. So there is no need to write any statement inside this setup function. And the next function is the loop function that we want to run continuously. So inside this loop function, we are basically writing LED1 dot update, that LED1 from the class we are getting this update function, and similarly for the LED2 from the class we are getting this update function. So what will happen when we will run this code on our Arduino Uno board? So when we are basically compiling and uploading the code into our microcontroller, and microcontroller will start execution, it will create the class instance, and it will come indirectly into the loop function, and inside this loop function it will execute LED1 dot update function. When this LED1 dot update function will execute, it will basically read the current millis from the millis function, and it will decide whether it need to turn on the LED or turn off the LED. Similarly, if we want to control the LED2, then after this it will run this LED2 update function. So you can see here that whatever we have discussed in the case of multitasking, we are running two tasks. First task is to control the on and off time of LED1, and the second task is basically responsible for on and off time of LED2. We are trying to running two tasks, but these two tasks we cannot run concurrently. Like we don't have multiple cores, so in one core we want to run these two tasks. If we are trying to run these two tasks in one core, then we don't want to block the code execution. If we are using delay function, then certainly our code execution is going to be blocked. So for that purpose we are using millis instead of delays, and millis is a very powerful tool that enables your microcontroller to perform multitasking abilities. So these two tasks are basically running independently with each other, because it doesn't depend whether if the turn on time is not completed for LED1, it is not blocking to calculate the turn on or turn off time for the LED2. To upload this code and execute this code, we can use these symbols which are available with the platform IO plugin. These are very familiar with the Arduino IDE. First try to build this code and see whether our code is working fine. Yes, we got the success message. You can see here that it is also telling you that how much RAM and the flash memory you have used. So I am using Arduino Uno board. So in this Arduino Uno board I have used RAM 2%, that is 41 bytes only RAM has been used, and if we have used 3.4% of our flash memory. So there is a lot of scope to control many more devices with this Arduino Uno, because we have a lot of memory, because we are having 32 kilobytes of memory available inside the Arduino Uno board. So let's try to upload this code with our Arduino Uno board, and I'm trying to upload this code. Okay, that's automatically uploaded. You are getting this success message, and it took only 2.72 seconds. So now my code is working fine. Let me show you the end result on the camera. You can see here that we have connected two LEDs. One is a red LED and another one is the green LED, and these two LEDs are continuously blinking with different on and off time. That's great. So guys, if you have any question or you want to know something regarding this multitasking ability of the Arduino Uno board, you can write your questions into the chat box that is available on this YouTube channel. And one more thing I just want to add with our discussion, that if you have any doubt that whatever we are doing with the help of millis, you can do the same thing with the help of delays, then I give you one assignment. Then please try on yourself that you have to control 3 servo motors with different rotations and the 3 LEDs with different turn on and turn off time altogether, and try to write the code while using the delays. Then you will easily understand what is the need of multitasking and how we are performing this multitasking ability with our microcontroller. So I'm waiting for your questions if you have any. I think there are no questions. So thank you guys, thank you for your patience listening. We'll meet again very soon.